Now, I think we would say overall the immune system is a good thing. We're glad we have an immune system. Most of the time it protects us. But when the immune system goes haywire, that's when we have difficulty. My mother right now is out of the hospital. She's recovering at home from antibiotic-induced immune hemolytic disease. Because some high-powered antibiotic they gave her caused her body to build up such an immune response, it attacked her own red blood cells. She was so anemic she could hardly get out of bed for almost a week. They transfused her with 2 pints of blood yesterday, and today she's at home feeling much better. But again, if this red blood cell immunity, which is going to be either T or B cell mediated, if it's still going on, those new red blood cells are in danger too. So they've even put her on immune suppressive drugs, which creates all other kind of issues. So immune system is good until something goes wrong. AIDS is one that we are pretty familiar with. Acquired immune deficiency syndrome. You'll hear a lot of people talk about the AIDS virus, and the AIDS virus is HIV. HIV is human immune virus. So if you say HIV virus, you're saying human immune deficiency virus. HIV is particularly insidious, if I can use that word from the movies, because the HIV attacks and attaches to the CD4 receptor. Now, do you recall what we said CD4? Where do you find CD4? And on which particular cells we said we're CD4 positive? 1-8 with 2 forks. 1-8 with 2 forks. So the CD4 is going to recognize MHC2s. MHC2s are going to be on antigen-presenting cells. So CD4 on the helper T cells. And remember, helper T cells activate the immune system, both the specific and the nonspecific, both B and T cell mediated. So if you take out the dispatcher, you're never going to activate the immune system, and that's largely what happens. Now, HIV is a retrovirus, simply meaning that it's an RNA genome, not DNA. And so within the genes of HIV, you have genes that encode for enzymes such as reverse transcriptase, which allows you to make a DNA copy of an RNA genome, so it's just the opposite. And then there's also an enzyme called viral integrase that allows that DNA copy to be inserted into the host genome so that the host cell becomes a virus factory. And this is a very simplistic illustration of HIV infecting a T cell, that virus taking over the transcriptional machinery of that cell and just making more and more and more HIV particles. But you can imagine, as the virus takes over the T cells and it makes more virus, your immune system is going to slowly be depleted. And in fact, there's several clinical stages of AIDS, the first being your primary infection. Now, this is a little bit like our primary immune response, because this is going to last a couple of weeks, maybe 2 weeks. You're going to feel bad, like you got a cold. And by and large, most people are going to miss the fact that they have contracted HIV because they get better. And you go to the doctor and, oh, you got a virus, take some Tylenol, drink some. They're not going to do an HIV test. Number one, it's much more likely you have a cold virus, and the test for HIV is much more expensive. So that's why it often is missed. Well, you get a cold for a couple of weeks, then 10 years go by, and you're fine. And this is the clinically asymptomatic stage. Remember, if you put A in front of a word, it means without or not. So you have no symptoms. But during this time, your HIV particles are getting higher and higher, and your T cells, your helper T cells, are getting lower and lower. Until at the end of our clinically asymptomatic stage, your T cells are depleted, they're gone. Your immune system is by and large shut down, and now you begin to have symptoms. And symptoms of various infections. So, your lymph nodes, where you have your lymphocytes, they're totally burnt out. Using some good East Texas vernacular, burnt out. Your T cells are gone. Your body cannot replace T cells anymore. It simply can't keep up with the demand. All the T cells and the precursors to T cells have been destroyed by HIV. So the longer this symptomatic period goes on, the worse the patient becomes. And so in our illustration, we can see our CD4 helper T lymphocytes in blue, viral particles in red. Here we see the first couple of weeks, as our HIV particles go up, our T lymphocytes go down. But look, after a couple of weeks, there starts to be a rebound. It's as if the T lymphocytes are beginning to win again. But now when we switch over to years, and we go out 10 years, your helper T cells go to 0. And your viral particles slowly creep up until after 10 years, when you start to see symptoms, and you see this upward spike is almost exponential, because it's a rapid decline from symptoms to contracting an opportunistic disease like pneumonia until death. Now, there's a lot of research, millions and millions of dollars going into AIDS research. There's a lot of medications that can extend your life, treat the symptoms, but we still do not have a cure yet for HIV, and thus for AIDS. Now, that's sort of the pinnacle of how bad it can get. But depending on what the substance is, you could have some allergies that make you feel like you want to die. And again, these are the allergies. Then we're going to talk about two types. One with antibodies, primarily the IgE isotype antibody, versus our T cell allergic response. But if it's either B cell mediated or T, we call it hypersensitivity, aka allergies. And you're not going to be born with an allergy. You're not going to be pre-sensitized to something at birth. You're going to have to be exposed to something. You're going to have a primary immune response that later is going to develop into an allergy when those IgEs get nested on those mast cell receptors. With a subsequent exposure, that's where we can start to have issues. As a Star Wars fan, I love this picture, especially around East Texas, when in the early springtime, it doesn't snow, it pollens all over your cars. So it can be quite debilitating for many people with their allergies to pollen. And the first type we're going to call type 1 hypersensitivity, or we call this immediate hypersensitivity. This is B cell mediated through our IgEs. And when we look at allergies that are mediated through these IgEs, it's typical for hay fever, asthma, food allergies, allergies to stinging insects. I do not like wasps and bee stings. I don't do well with those. It's not deadly for me, but I have a pretty bad reaction to these chemicals. And if you have, or if you know someone that has allergies, and they're severe enough, they've probably gone through testing. And largely the testing for allergies is the same as it's been for decades. They're going to take little needles. They're going to put the allergens on these needles and stick your skin to see if you develop a little welt. And if you do, they'll know, okay, you're allergic to whatever that was. Now, a lot of people say, okay, well, I'm allergic to this, so I won't eat this food. I won't live in this particular area. But if you develop an allergy to pet dander and you've had a little dog for 10 years, well, it's not likely you're going to avoid that allergen. So that's really where medications come in, immunotherapy, but you have to know what it is you're allergic to. And so even though this looks somewhat old school, this is still largely how it's done. They do it a lot of times on your back if you have a number of these, but they make these little red lines on your skin, and then they add the allergen at the ends of the red lines to see, okay, if I put this allergen on the skin, are they going to have a reaction? And when you look on the right, these welts you see, pretty much that individual's allergic to whatever that allergen was. And we've got apple, we've got walnuts, so a lot of your food allergies, common allergies that we have, those are the things that you're going to be tested for. And you'll get a report back of what you are or are not allergic to. Now there's a sense of being allergic to something if you get itchy, if you have a fairly swollen welt that occurs because of an ant bite or a mosquito bite. But then there is the worst case scenario where you are so allergic to something. And a lot of this is going to be your food allergies or things you ingest or inhale. That you have so many mast cells activated and release so much histamine and heparin that you go into anaphylaxis. And with an allergic type of reaction, you're going to have a lot of histamine and heparin, so you're going to get a lot of edema, a lot of swelling. And if this happens in the mucosa of your airway, you're headed for something that's called anaphylactic shock. Swollen airways, you're going to have difficulty breathing. Systemic vasodilation, every blood vessel in your body is wide open. Your blood pressure plummets. You lose consciousness. You're not conscious, you can't breathe, and in a matter of minutes, not hours, not days, but in a matter of minutes, if you don't get help and attention, you will die because you will basically suffocate. You can't get enough oxygen to your tissues. And so what do you do? And what does someone that has a severe allergy keep with them at all times? An EpiPen. And what is the pen full of? Epinephrine. What is epinephrine going to activate? Which part of the autonomic nervous system? Sympathetic, fight or flight. Your heart rate's going to go up. Your blood vessels are going to constrict. Your airways are going to dilate. You see how that offsets everything that this allergic response is doing? It's the opposite. So you have to give them epinephrine to cause your blood pressure to go up and cause your airways to open up. And if someone has an EpiPen, hopefully they have multiple EpiPens. Because if your EpiPen is at home, what good is it going to do you at work? If your EpiPen's in the car, what good is it going to do you in the classroom? But here's the other thing. Do you know people that have EpiPens? Do they have medical alert bracelets on? If they are alone somewhere and they have an allergic reaction and they are unconscious, how is a stranger going to know that they've got an EpiPen and they're having an allergic reaction? They need, in addition to the EpiPen, they need an alert bracelet, necklace, something that allows someone on the scene, like a first responder even, to know how to treat them sooner than later because they're running short on time. Now that was type 1 hypersensitivity, B-cell, IgE antibody mediated. Delayed hypersensitivity, this is going to involve T cells. Now type 1 was referred to as immediate. Delayed is type 4 hypersensitivity. I don't know what happened to 2 and 3, but this is type 4, delayed, because it may take upwards of 3 days to realize the symptoms of an allergic reaction. Now, this is not uncommon in transplant rejection, which is T-cell mediated. But we're going to see that this can be This can occur from mycobacteria, fungi, parasites, or even toxins. Toxins produced by certain plants and certain animals. So when we look at the lists of things that can cause our delayed hypersensitivity, contact dermatitis resulting from poison ivy. Is anyone else in here allergic to poison ivy? No? Y'all are missing out. I look at a picture of poison ivy and I break out. I do. This stuff, my stepsons, they can grab it and rub it on them and nothing. I see them do that and I start getting lightheaded. It's like, oh, can't do it. TB skin tests. If you've ever had a TB skin test and there's a result, that's why you have to go back in 2 days to have it read. It doesn't get read immediately because it's a delayed hypersensitivity reaction. Now, we can also have graft versus host disease, which is the opposite of a transplant rejection, which is an allograft rejection. Graft versus host disease is, say, for instance, when you get a bone marrow transplant. That bone marrow is a brand new immune system from the donor. And if that donor's immune system doesn't like you, recognizes you as foreign, that new immune system is going to attack your entire body. That's graft versus host, and that'll lead to a delayed hypersensitivity reaction. See, that's poison ivy. Again, I look at that and I just itch. It doesn't come up right away. It takes 2 to 3 days, but if you get in it, you will know it in a very short period of time that you are having a type 4 type of hypersensitivity. Now, let's say you get tested and you are allergic to certain substances. Well, they may give you immunosuppressive therapies, or you may undergo what's called desensitization. This is where slowly over time you are given a small amount of the allergen, not enough to give you a severe allergic reaction. But what you're trying to do is essentially immunize yourself against the allergen. And you're wanting your body to produce a primary immune response so that now your body begins to make IgG antibodies. You've got the memory cells. The next time you see this allergen, you produce a ton of IgG. So when the allergen comes in, the IgGs are more likely to bind it just from a statistical sense, because there's more of them, than the IgEs on the mast cells. And if you can overwhelm those mast cells for long enough, they will eventually die. They don't live forever. And you will lose those mast cells that are pre-sensitized, and then you're not allergic anymore. That doesn't happen for everyone, and it doesn't happen for every particular allergen or even situation. That's one reason, in fact, if you have allergies to pollen, what is one non-prescription method that some people try to desensitize themselves to pollen? What is something that they try to find that they eat? And it can't just be any brand, and oftentimes you can't just buy it in Walmart. You have to go to a farmer's market to get it. Homegrown and home-collected honey. Because a lot of times the honey we get in the store has been purified, it's been filtered, but if you go to the farmer's market and you find some locally obtained honey, often that's going to contain pollen. Pollen from your local area in small quantities. Small enough that as you eat the honey, you slowly begin to desensitize yourself to that pollen. Doesn't always work, and if you've got a severe pollen allergy, don't try it without a doctor's direction. But that's why a lot of people will essentially try to find this homegrown honey. And again, farmers markets are the best place to try to do that.